Today, well, I'm playing with intrusion detection system for my PhD, and today I will present to you something that we just finished to develop, or almost there, and it's an anomaly intrusion detection system that is specifically built for the web-based context. Okay, so like web server, web services. There are some warnings that I would like to give before starting. So, first one. What you're going to see is not the so-called silver bullet. So, this system is not 101% perfect. There are something that is not able to do, and you must expect this because intrusion detection systems sometimes fail. But this doesn't mean that there is something more to see today. And this talk is not just about like reaching 100% detection rate, so I'm able to catch everything, and I'm doing that with the 0% false positive. So stay here until at least the 10th slides, and then you will see what I would like you to show that is different than the other system that you could have seen before. And then the last warning. I know we are all having a hard time because it's just after the lunch, but I'm not going to show you naked woman to catch your attention. Sorry. So, this is what we are going to see today. Well, we will talk about brief introduction about the web application insecurity. What we have already out there and why it's not working. And then let's try to define what we want to do with this kind of stuff, with this intrusion detection system. And then I will present you what we have done in reply to those questions. So, well, everybody knows the web application today are doing everything. You have webmails, you have the content management systems, the bulletin board, e-commerce, e-banking, e-everything. There is the Microsoft Live search engine, Google, that started a long time ago. So basically, everybody is using them. You cannot avoid. And to deliver new services, to deliver new functionalities, a lot of new technologies have been developed or joined with them. Like, for example, okay, let's say that in the beginning of the 2000s, they had the DBMS support on the back end. So now we can store the data inside the DBMS. And then we had the evolution of Java and ActionScript. And now we have something live also in our pages. They are not just statically built. And now we have Ajax. That is, you must have Ajax or you are just a loser. So every 2 or 3 years we are seeing a new technology that is pushing even more far the web applications. Why they are so attractive then? Because every information, credit card, money, everything is there. So they are really attractive for an hacker. The point is that they are insecure. Why? Well, it's simple. A web application is insecure for the same reason why an application is failing, because there is people with a lot of different skills that is working on them, and maybe they're not coming here, they're not following any kind of programming course at the university, and that is why the web applications are failing, because they are written in a very bad way. This is just an example. There is like a lot of people writing PHP scripts. Even my sister is going to do that maybe. And nobody is checking. You don't know what exactly is inside the code, and you are not going to audit every single line of what you're putting on your web server. So that's the reason why. Because there is a lot of people out there that is writing web application and they don't have any idea of what they are doing about security. They're providing functionalities, not security. So, Symantec, and this is I think the first time that I trusted what they said, they made some statistics, and they are telling us that, and this is confirmed by the way by the fact that there are so many people out there just 20 meters far from us, saying that they have the web scanner, the web something to catch the bad guys. So they're saying that 69% of the total vulnerabilities that they have counted in the first 6 months of the 2006, they are related to web applications. 69%. Then they are also saying that what they so-called easy exploitable vulnerabilities, that means that you just send 200 bytes of something, of characters, of binary data, and you are exploited the bug, the vulnerability. 78% of these kind of stuff are related to web application. That means that, your young cousin of 10-year-old can do that. So they are saying, like, they're giving example to us, like SQL injection, cross-site scripting, or this kind of stuff. So, well, you know, if you are receiving the bugtrack mailing list, you know what every day is coming. Oh, the SQL injection in, well, it's the last known web application, but there are something like 10 or at least 20 vulnerabilities reported per day about web application. So, what you can do currently? Well, right now, for example, if you are here, you are almost knowing Snort. That is a network intrusion detection system. That means that it's working, looking at the packet going on the wire. And, for example, Snort has 1,200 signatures related to the web in general, but they are almost only for web application. And what? Nothing. There are still these kind of warnings, alert, and we are getting exploited every day, and you don't get it. You don't catch the bad guy doing that. Because there is always the same problem. The zero-day attacks, or the hacker is able just to modify slightly the previous attack, and the signature will not match anymore. And then, of course, there is another problem that it's quite common for network intrusion detection system, that is the SSL traffic. So you cannot analyze everything. In particular, you must provide the key that was used to encrypt the data also to the network intrusion detection system to be able to analyze this kind of traffic, and not everybody is going to do that. So most of the time you're going to miss those kind of data. Okay, so somebody say, well, why we are still coping with this? Let's make something new. Let's make something that is working with this under these constraints. So let's develop the web application firewall. And Mod Security is one of the good examples. I think Branch is out there, and they bought it something like 1 year ago. So this is an additional module for the Apache web server, and that means that you are able to inspect everything. Practically, you are the web server in that moment. So no problem anymore with SSL traffic, no problem anymore, for example, with post data. And this funny tool can import the Snort signatures, or you can define your own one. So that gives you at least quite, you can protect also your own web application, not just the one that the Snort signatures have been built for. One problem is that this stuff has some anomaly detection feature, but they are only related to the field of HTTP. So it can detect, for example, if a field is not carrying a number, what something different, or really, really small capabilities. And they are only related to the header of the protocol. So there are so many smart guys out there. What they are doing? So they said, well, why don't we build a specific auditing tool for the PHP script, or ASP, or Java, whatever. So basically they were just porting what has been already done for C++ and C in general languages to the web-related script languages. Okay, but this is not always possible, because I could have like a Java servlet that is in binary code, and maybe it's a third-party module that I have just bought, so I cannot do anything with it. So and anyhow, there are some problems like, well, there are the same problems that there are with the normal tools. You cannot always predict what is it inside that variable, and in the end they are failing. So somebody said, okay, well, let's take the web server log and let's try to make some analysis on that. For the first time they said, well, one good way to do that is to analyze the parameter. So they can take every parameter, they strip off the parameter from the log, and they say, okay, let's make an analysis on the content. What the client asked me. So for example, they were going to make an analysis of like ID equal blah, 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 and action equal blah, blah, blah. And they were applying some detection models on that. Okay, but in this case, if you don't use some special tricks, you cannot analyze the post data. Because the post data, for example, is not normally logged in, so you must add a new model. And, for example, if the attacker is smart enough and is able like to inject something, like he is using some kind of buffer overflow, he can prevent the web server to log that. You could miss the data, so the log could be tampered, and you will never know this with this kind of solution. So again, not good. Then somebody say, okay, let's try to restrict the domain of analysis. Instead of looking at everything, let's do that for the two most important vulnerabilities. So they developed something for SQL injection and cross-site scripting. There is a problem. For example, they are asking you, okay, they need to modify the source code of the libraries, for example, if you are using a bridge library to go on MySQL or whatever. They are asking you to modify the source code or the library itself to analyze these new data. Okay, what about SQL servers? I don't think the Microsoft is going to give them the library. And then there is a big problem with all of them. If you're thinking about, like, these web applications are carrying out also today, like, emails. And I'm writing, when you're writing an email, you're not writing, hey, I'm coming back tonight at 8, full stop, and send. Maybe it's something like 10,000 words or something like this, and it's really long. And all this is going to fail with that. They cannot analyze this kind of input. So again, they are useless. Now I want to tell you a story, and we are coming to the real point. Let's think about this. Why? So there are these nice, we have seen all these solutions, but they are not out there. Not even one of them is real, somewhere. At least for very small, just for the SQL injection, for example. No, nothing is out there. Why? So, let's try to understand this. This is my opinion about why they're not out there, and that's why today I'm presenting this to you. There is somebody that is telling you, okay, guy, I can give you a car that is able to speed at 400 kilometers per hour. But, not bad, and you have to do only these steps to drive at that speed. First of all, you have to speed at 300 kilometers per hour with the same car. Then you must stop. Then you have to switch on some buttons. I would say that you have to call your lawyer. And then you can restart the engine and speed at 400 kilometers per hour. But you can do that only for 12 minutes because, we had some problems with the cooling system, and then anyhow we need space for turbos to give all that power. So you have to find quite quickly a petrol station. So would you ever buy a car like this? Nobody would, because you cannot manage. It's impossible to manage. You can manage maybe once, twice, but you will get bored the first time that you have to do all of this just to drive a car. Better to take a Ferrari that is not going at 400 kilometers per hour. It's not costing 2 million euro. And, well, you can stop after something like 3 hours of driving. So this is the same problem with intrusion detection system, with anomaly-based intrusion detection system. You cannot manage them. All the solutions that you can find today let's say in the academy, for example, or, The best one, the one that you will say, wow, this is cool, and this is unmanageable. This is the big problem with intrusion detection system, with anomaly-based intrusion detection system. So, by the way, if you want to buy this car, it's this one, the Bugatti Veyron. They've sold 5 of them or 7, but it's nice. I mean, it's cool. Once in your life. Okay, so we have to overcome all these problems, because otherwise we are just providing another 100% detection rate, zero false positive. It is unmanageable, that you will get bored, because you will need specialists to manage it. You will need to train your people, you will need to send them somewhere, they will spend a lot of time on writing the signatures, setting threshold, and so on. So we must make something usable, finally. So, of course, we have to overcome the same problem of the post data and the secure socket layer encrypt data. Then we have to overcome the problem of the source code, if you don't have it, if you are buying a third-party module to put on inside your web server. And, of course, we cannot use the logs. Then, of course, we want him to be anomaly-based, because we want to catch the zero-day attack. But why, especially the anomaly detection system, are unmanageable? Because the first requirement that they want, that they need to really work properly, is this. You must provide them a cleaning dataset. And now I really want to ask to the people out there how they're going to make clean dataset in their experiment. They're just saying, oh, I got clean dataset somewhere. Good. I don't, and nobody can. So we must apply something to at least not really provide a clean dataset, but something must be out, something must be pop out. And we want him also to be self-instructing. We will see later what this means. So, with all these properties, we can detect the zero-day attacks. We could generate signatures also for other systems that are not so smart as ours. So this makes the deployment of this stupid intrusion detection system easier. So, are we just dreaming, or is it possible? Okay, this is not the silver bullet, but this is this. So, to satisfy the first two properties, we have to make the same deal that mod security did. So we must be an Apache HTTPD module. Because only that way you overcome the problem of tampered logs, post data, SSL easily. Then our solution is anomaly based, so we can catch the zero-day attack. And how we're going to do that? Well, we are putting together different techniques combined at the same time to increase the detection, so to catch 100% attacks, and the accuracy, to lower down the false positive. But we have also to do something more to do just to achieve this goal. We have to pre-process what will be our training dataset somehow to push out everything the much as we can that is bad. How we will do this analysis to increase the detection and lower down the false positive? We will follow the same road, the same path that I showed you before. We will make a parameter content analysis. But different from before, we will be a little bit smarter and we say, well, if that is a number, I will treat it like a number. I don't care because it's a number. It's not going to change. Or if it's an email, if it's a long text parameter, then we have to treat them differently from before. We cannot use always the same time, because the same model to analyze the content. And the last and the most interesting feature, I think, is the following. We can generate the signatures in an automatic way for mod security. That it's the widest web application firewall deployed in the world. So the guys will not lose the mind writing the signatures because somebody thought it was nice to add a new parameter in the web application. Okay. I guess the picture is not really the best. I think I have to visit the Guggenheim Museum once more. But this is what we thought could be a good solution in case, of course, you don't want to protect only Apache. Because in that case, we are just protecting, okay, we're protecting half of the world. But there is more. There is Microsoft, there is Sun, there is a lot. So if we put our model inside a proxy, and everybody, if any enterprise company today have a load balancing system for their web servers. So that means that we are just putting something somewhere that is already in place. We don't need to add new hardware. If we put our model here, then we can protect everybody without putting too much effort. Okay? It comes for free to protect Apache and IIS at the same time. Okay, so now we're going to talk about the engine. What is it really inside the stuff? So, first of all, as I said before, any anomaly-based intrusion detection system is going to go through a training phase because they need to learn what they have to protect. And this is the biggest point, because if you provide them a training data set that is containing attacks with some dirty noise inside, the system will learn it, the system will use it, and it will not detect it after. That means that you will lose the 100% detection rate. So, because nowadays we have both botnets scanning 24 hours per day, automatic scanners, script kiddies, that they are doing everything, searching for well-known vulnerabilities, finding the worst configuration possible, and so on. We must find out a way to clean it. We have to avoid this noise somehow. Let's say that, of course, if this was a good detection technique, it would not be used to clean the data set, but it would be used to detect real attacks. So what this cleaning phase can do, it's not, I would not say so little, but it's not so big. And let's say that you can detect in this way, you can detect, like, for example, most of the probes or the scanning activities that the automatic scanners are doing. So, how it works. We are receiving a stream of HTTP requests. So, differently from other, like, for example, different from a network intrusion detection system, we are seeing a layer up. We are at the application level, and that's why this thing is working better and could work almost only in this context. So there are parameters that we can extract, information that we can generalize for each request, like, for example, the received and sent bytes. Which kind of response code the web server gave us, the duration of the communication. And as I said before, this technique is not really smart. So the detection rate is low, but it's low enough for what we have to do. So here the request comes, we go through this classification. If we accept it, then we will pass it to the real anomaly detection engine for the training. Otherwise, garbage. What we are going to analyze in the real detection engine, because as I told you before, in the cleaning phase, we are just popping out numbers like bytes and bytes received, sent, and so on. Okay, this is a common HTTP query. It's a GET. from the content management system post-nuke, so it's quite famous. So here there is a parameter called the name. This guy wants to see the news, and he wants to see the article, and he wants to see the article number 25. So as you can see, we can divide, like we can classify the parameters based on their type. Here we have something that is a number, and it will always be a number. And here we have something text-based. So we have already said that the content analysis, it's the one that is providing you the best result. Because you can make good assumption on what you should find here and what you should find here and what instead you are finding if it's an attack, for example. So if we are observing the seed parameter and then we know that it's only a number, it must be only number there. And, oh, well, there is some text popping out. What could be? Could be a SQL injection or a cross-site scripting or whatever it is. I don't care. But for sure it's not a number anymore. This is an attack. So this is like the basic idea of the approach. Okay. So we have this detection engine that has like 3 subsections. One is the one that has to recognize and learn which are the numerical parameters that we have. Well, everybody knows that, for example, we have DBMS table entries commonly. Like, I want to see article 25, so the web server will process the request, the DBMS will send it back the row number 25 with its content. So, for example, for this one, we are using just a type checker. Once we learn that it's a number, we just check that it will be always a number. Then we have the second type, the short text. What we call short text is something like there is a fixed length or almost fixed, like less than 15 characters, and with almost fixed content, like func equal delete or add or view. These are commonly fields that you find inside the web application to list user, to delete user, or to do whatever, to log in or so on. And then we have, and for these we use a grammar checker. Later we will see what we mean. For the last type, that is everything remaining, we call it raw data. Can be emails, like, or binary data that you are sending to the web application, like your picture, because you are updating your profile inside the MySpaces. Executables, PDF file, whatever it is. Okay, so we had developed 2 years ago a network intrusion detection system that is called Poseidon, that is here. And I will show you later how we modified this to adapt to this new situation, where it's different and why it should be here. So right now we have this engine combining 3 different parameter type, and once the first request comes, the engine learns all the type of the parameter, or at least try to discover as soon as possible the type of each parameter, and then it will use the same model later in the detection phase to check if it's something normal or something bad. So this is again, like, this is the data flow that the information is gonna follow during the training phase and during the testing. So during the training phase, the request is coming, the classification is telling me it's okay, you can use it for training the engine. The engine discovers the parameter type for each type in each page or in each resource, and then is feeding the appropriate model for each parameter. So if it's numerical, if it's text or long text raw data. When it's testing this phase, the classification phase, it's not used anymore. Okay, so let's look at the first 2 parameters, the first 2 types of parameters. So the numerical model just has to discover if it's an integer number, if it's a decimal number, and it's just checking that the later request will be matching this. If we are still receiving number, this is the simplest one. Everybody can understand just thinking about it. The point is just the system learns that that is a number actually. Then we have the short text model. So, the grammar checker. I don't know, well, not everybody here made studies in the computer science field, so let's try to make it as simple as possible. Let's say that you are observing some text, and you have this sequence, like my short text, and you feed in to an automaton. This is the automaton. So the automaton is just telling you which is all the possible state that you can find when analyzing the string. So like my short text is starting with M, and we have M here, then there is Y, and it goes on. And then, for example, we observed that we can have my short text 1 or my short text 2. So this stuff is like summarizing all the samples that we have seen, and it's building for every sample, is analyzing, and if needed, building something like this, describing what we can see. For example, we could have my short text and my long text. So here, where there was the Y, we would need another arrow going to the L to represent this information. The good stuff about grammars is that you can make them general. You can derive a regular expression. So, for example, if we have a cookie session, a cookie belonging to a session parameter, and this is the cookie, we don't need to, of course, every time A, B, C, then we will find the E, F, G, H, and then Z, Y, W, because it's a cookie, it's changing every time. So how I'm going to catch that? I cannot build for each cookie that I've seen an automaton. It would take too much space. But I can make a regular expression out of that. So from this, you can always derive this, most of the time. So from A, B, C, D, 1, 2, 3, 4, D, F, G, I can go to this. So this regular expression is telling me that the only sequences that I have observed during the training were made like letters, numbers, and letters. Nothing else more. So if somebody is putting plus, at, backslash, or whatever it is, it's not going to accept it. Of course, when you're making a regular expression, it could be that you are allowing yourself to say, well, this is okay to a larger group of data. Like, you trained your system with 1,000 samples, you should expect only to accept those kind of samples, but could be that you're going to accept something out of that original domain, because you have the regular expression. The point is that it's quite difficult, for example, from this expression to fit in something like plus, at, or strange character that you need to inject when you're making, for example, a SQL injection on a cross-site scripting. So let's say that the idea is it's difficult to derive from this one to craft from something that is suitable for this regular expression and anyhow to get your final goal. It's quite difficult. Then we have to cope with the following problem. Because I told you we are observing 1,000 samples during the samples during the training phase. Could be that we are building an automaton for each one of them, because we cannot find any similarities between them. We cannot build my short text 1 and my short text 2 at the same time, just adding a 2 in the end. Maybe we need something more. We need to build a new automata. So let's say that in during our experiments, we saw that if you're going for more than 10 automata, the analysis just become totally infeasible, because you will need so much space on the disk in the memory that the system is going to crash. So what we are doing also for the short text model is tracing also the length information. So we will see how long the samples are. So let's say that commonly you get a sample that is 10 characters long, plus minus 5. Okay, so you are in that moment you are allowing the system to the intrusion detection system to accept everything that is between 5 and 15. And now something of 200 is coming. Well, that's quite weird, and the system will raise the alert. This detection using the length information has been proved to be quite reliable. I mean, it's quite good. Of course, if you have if your length is saying that the maximum allowed is 15 and the attacker is able to put everything in 7 bytes or 7 characters, it's not gonna be detected. This is, for example, a parameter search that we met during our experiments, and as you can see, this stuff is quite long. I mean, we couldn't derive anything. Okay, there is plugin, there is external, there is known, but the previous part is completely random. So this is typically something that for which we would use the length information instead of generating the regular expression, because you cannot derive anything from here. It's too difficult. Okay, now we have the raw data model or the long text, the emails basically, or the binaries that you are sending to the web application. So as I said before, it's like a modified version of our previous network intrusion detection system, Poseidon. This system is taking a single network packet, is taking just the payload information, so just the content, not header, nothing, just the payload content of the TCP stream, or the one that is going to feed the application. And there are 2 layers in these, 2 layers that joint that are used to make the analysis. So the whole payload is passed to a neural network. The neural network is making some analysis on it, is giving us a classification. This information is passed to the real detection engine that is based on n-gram analysis. It means that it will consider like the length, the frequencies of each byte and the standard variation of each byte. And both, I don't want to bother you with this because there is the paper in the references and maybe you have seen it last year when we presented here. So let's say that these information joint are used for the anomaly detection to detect the anomalies. It was working quite good. It was a general approach for each network service. I mean, with not only web, but also SMTP, FTP, and so on. But in this case, we cannot use it because the basic analysis unit is the network packet. Here we don't have network packet. We must come out with something different. So this time we have a stream of characters. And we have to cope with this. So we said, okay, instead of taking the network packet, we can take the stream, divide the stream in blocks of n character length, so we can like modify this length. And then we use this block to pass it again to the neural network that will again classify it. It will give us the classification, and then we will also pass the whole payload again to the same engine for the n-gram analysis about frequencies of bytes. In this way, we are not bounded anymore to the network packet, and we can have, let's say, the same correctness in the analysis, because the system before was really working quite good for network packet. So we have the stream. We could find inside it, if we are using length 5, we can have maybe something like 200 blocks. And when it's the anomaly, because before it was easy to say if the whole payload was anomalous, because we got only one answer from the system, anomalous or not. So it was easy to say when you had to raise the alert. In this case, when I'm going to do that, when I find one or what? So the answer to this is when I'm detecting at least a number of anomalies in a single stream that I'm analyzing, I will consider it anomalous. And because, for example, if you are injecting something, if you are injecting a buffer overflow, you will find, for example, the first block and most probably also the second, the third, the fourth, the fifth in a sequence, because the stream is, that part of the stream will be anomalous for like 100 bytes. So, the problem that the other system had, it was again a little bit unmanageable, because we had to set the threshold to know when it was anomalous or not. And we could do that in an experiment, but if you were going to real life, it's quite difficult, or I mean, you will spend some hours. So we said, okay, let's see if we can get rid of this. Yes, we can, because, of course, the threshold settings, I mean, if I'm setting a threshold value of 10 or at 20, the false positive rate and the detection rate will change completely. So we tried to get rid of this, and we say, okay, we can use this parameter as a threshold setting, and so the number of anomalous n-gram inside a single stream, and we saw experimentally that this is a good value. So n equal to 5, so we are analyzing blocks of length of 5 characters, and when we find 5 anomalous blocks, we are raising the alert. This is quite reasonable. It's easy to change if the user wants, and will not lost your nights thinking which is the best value to put there. So this is again overcoming a little bit the problem that we had before. Now, the benchmarks. Okay, this is the most famous, most used, because it's the only one, dataset, public dataset around the world. It's called DARPA 1999. We were testing with this dataset also previously Poseidon, so we use it the same just to show that this approach is better than the previous. Like Poseidon was achieving 100% detection rate and some false positive. Sphinx is achieving again 100% detection rate and with 0 false positive. Okay, this is really a stupid data set. Unfortunately, the world is not able to sit down, think, and come out with something new that will reflect the 2007 data traffic. So, yeah, it was easy. And now let's go for something serious. Again, in our research, we applied, we were making experiments and we collected a private data set in our university. Well, you would really be surprised what the people in the university is doing, but it was full of everything. Like they were requesting MP3. This was our department main site. So our shop window out of the world. The world was coming to see what we were doing. So there were MP3 files, PDF files, porn movies, and so on. So there was it was really garbage. You could really find garbage out there. This website has something like 1,000 requests per hour. And we have found evidence of SQL injection and cross-site scripting attacks that were manually crafted, by the way. There were some buffer overflows and a lot of scan attempts for well-known paths like, my PHP admin and something like this. By the way, for example, Norton, this data didn't find anything. The latest rule set of Snort didn't find anything. So, with our previous system, we were able to, when we were achieving the 100% detection rate, that it's always possible with an anomaly detection system, you just raise the threshold, you just lower down the threshold as much as possible. We were getting a total of 2.85% of alerts. That is quite a lot if you consider that we had 1,000 requests per hour. That means that A lot of times, the web administrator was going there and say, oh my God, what is now? Oh my God, what is now? With the new system, we were able to achieve 0.2% of false positive. I personally believe that this is, I mean, if you do the same cleaning if you apply the same cleaning data set also for this is not gonna lower down too much. So I believe that this is because the three analysis techniques combined together are really working. It's not just because we were cleaning the data set in that automatic way, for example. Because somebody was asking me before, well, maybe it's because you were cleaning it. Okay, we cleaned it also for this and it didn't work. Now, the really cool stuff, for me at least. Okay, maybe you have seen that there are somebody saying, okay, my anomaly-based intrusion detection system can also provide for you the signature. So once it has discovered the zero-day attack, it will provide for you the signature. Okay, this is true. I mean, the system will generate the signature. What are you going to do with the signature? It's unknown. I mean, it's not working. If you see some system also like provided by the Academy World, they are completely useless. I mean, okay, yeah, the attack was correctly flagged as an attack, but the signature that they come out with, completely useless. And you cannot rely if you're deploying your own web application system because you are a bank or whatever you are, a merchant, eBay, whatever. They have all their own web applications. So the signature of Snort are not working because they are general. They are for other stuff. So you have to spend a lot of time in writing your own signatures if you want to catch the bad guys. So, first of all, we are not generating signatures from the attacks that we have detected. But we are generating signatures for what is allowed to pass. So, once our system has learned what is allowed to pass during the training phase, it's producing the signatures for the numerical values and most of the short text parameter in the format suitable for mod security. So, for example, this is the signature automatically produced for the ID parameter. Or we have func here, and we add delete and view. So in this case, for example, we are accepting only these kind of values. So we are like reverting completely the normal meaning of signatures. Instead of catching what I know is bad, I'm rejecting everything that I know, that I'm accepting only what I know is good. This is like a firewall kind of orientation. Okay. This is the signature generated by Avast system. This is the same signature of mod security that is commonly packaged for you in the rules. They are doing exactly the same thing. You will get exactly the same. Now, maybe with this one you're losing something. So here you will see a command shell file list. So they are trying to catching actually SQL injection. With this, you are accepting only numbers for that parameter. And you know that there must be only numbers there. Okay, now I have a short demo. It's really short because the time is really tight. So, in the very origin of this project, this had to be an automatic generator of signatures for mod security, for the short text and the numerical field. So we just said, okay, let's write it in Java. It will be a nice script that we can run and so on. Here I have two logs files that a good friend of mine gave me for this purpose because my university didn't allow me to bring the one that I made the experiment on. So if we look at them, they are from post-nuke installation. So you can see the normal post-nuke request, like this one, and so this guy wanted to see index news, the language was Italian, what more? Then, like for example here there was the browser, and so on. So, normal stuff that anybody installing post-nuke will have on his website, on his web server. Now, we run. It's finished because it's only 1 megabytes. And here we have the rule. So, for example, here we are saying that, for example, we are setting only ET, Italian, Deutsch, English, and French. Nothing else more. Or, for example, here we are setting only page head, that it's a module for post-nuke, archives, and news. And we have analyzed 1,960 samples. The first one is new lang, ITA or English, Italian or English, 2,279 samples. If we go down, these are all the signatures for the numerical parameters. So, for example, well, these one are really few, but this one is 912 times. So, in less than what? 5 seconds, this website is protected. On this website, nothing is going to enter anymore. Okay. We're running really out of time. Okay. It's time to finish, and especially for the question. So, this is the first totally automated, anomaly-based solution that the Academy has produced, and I hope the word. Which are the main features? So we are inferring the parameter type, observing the data as they come. So we have these 3 basic types: the numerical, the short text, and the raw data, or long text, whatever you want to call it. And we use different models, not at the same time on each parameter, but for each parameter we identify the type and we use just one model on it. The best thing is that we can generate the signatures in an automatic way, as you just saw, for what is allowed to pass. So we're not generating signatures for what is bad, we're generating signatures for what is good. In this way, you can acquire like a third-party model and just plug in this. The user are starting to use it, and you will have immediately the signatures for mod security to have your system protect without wasting time with your IT specialist getting a very bad headache and so on. What we cannot catch, why this is not the silver bullet. If you were here this morning at the David Maynor presentation, then you should have understand that, for example, the attack that he made is simply like he was able to dump the cookie session, the session number of a user, like using any webmail, like Google Mail, and then he was able to use the same number to get in again when the user was not in. That is an attack to the logic of the application. We cannot catch something like this because everything that the guy was passing today was legal. There was nothing, there was not a buffer overflow, there was no injection of anything, just what is legal. It was observed before, the system knew how to generalize it, even with, there was no way, any intrusion detection system would detect that, because it's an attack to the logic of the application. So this is something that is lacking, and unfortunately, I believe that the only way to do that is to programming in a better way, or to write smarter programs to check. But anyhow, the programs are already show that they are not good enough in analyzing the source code and find out what is wrong. What we are doing right now is, okay, we developed blah, 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 everything is okay, but we want to test it in real environment. So, luckily, in my user committee, there is a Dutch security outsourcer and they really like it. So they would like they want to put it in their customer site, or at least they want to use it to analyze what is coming back from their customers. And so these days we are making the final agreements, the final papers, and so on, because we want to see how the system behaves in the online, when the system is going online. So that means operating real time. They have e-commerce sites and banks also, so it's good platform to test because it's what the world is doing. We're not just looking at personal pages on a website. So this is it. I don't know if you know that the Sphinx in the past, in the Greek mythologies, was a lion or something like this, waiting people before the city, before a Greek city, and she was asking a question to them, and if they were not able to answer, she was killing him or her. So I don't want you to kill me, but now is the question time. So, yes?
Multiple questions.
Yeah.
One of the questions is, you talked about collecting a private data set in your environment. How much data did you have and how much did you use for training versus testing?
Okay. So the question is, how basically which are the ways we collected our data and so on. So we collected something like 10 gigabytes of data because that stuff is producing something like 600 megabytes per hour of traffic. And we randomly choose a shot of 600 megabytes for the training. And then we had the other 1 gigabyte and 200 megabytes for testing. Again, randomly chosen. So we just decide what to use as training, and it was like left there for the Poseidon test, and then we had to clean it for the Sphinx test. And with the testing phase, we just look at it inside to find out the attacks.
How many users would you say there were?
1,000 per hour.
No, how many users?
We were doing that. You mean we were?
How many users you had for the server when you were collecting data?
Mm-hmm.
How many users or how many people were using the system?
1,000 per hour.
Users?
Yeah, they were. We had. Unfortunately, there is. I believe that most of them were like automatic scanner or something like this, but there is that kind of people looking at.
Did you also look into any other training mechanisms? Because I think neural networks, they might be okay, but I think they're very slow. It takes them forever to train.
Yes. Right now we are evaluating other techniques. Unfortunately, I think that doing that in an unsupervised way, because that is the problem, that it must be unsupervised, because anyhow we are getting again inside the circle. If I have to put somebody clicking yes or no to classify the attack before feeding the system, we are again wasting human time. We are currently evaluating them. But because in that moment you are in an offline, you can do that also offline. The training of the system can be done offline. So in that moment, exactly as I told you, that's what we want to test when we're doing the real life test. We want to especially to test the online capabilities of the system.
And the last question is, you talked about using regular expressions
Yes.
for signatures and to clean up the data. Do you think it will pose as a limitation if there is a small deviation? Because regular expressions are very fussy about stuff. If there is a slight change in your data, it will just reject it.
Okay, that is a good point. Let's say that the data that that came to our website was really random most of the time. So that's why I would like to see it also in the real world, because I believe that there is more regularity. But anyhow, if there is something really random, then we will just use the raw data model, and in that case, it's quite working good. So we will complete. That's why I said for some parameter, for most of the short text parameter, you can generate the signature. Because if it's really random, then of course you cannot. Like I showed you the signature that I showed you before. Like, what was that? Bah. I lost it. Anyhow, there are some limitation, of course, in the way you can generate the regular expression. So for most of the parameters, it's working, and you can come out with something. What I would say is that the best solution to do is to combine at the same time like mod security and these on the same machine, and when like mod security is routing or leading the first time of the first part of the analysis, and then our system is leading the second part. So if mod security can already find out something, good. Otherwise, you have to go for like a hybrid system combining anomaly and signature-based techniques. Any other questions? Yeah. Not yet. It's also not yet, because no, the problem here is that unfortunately I have a user committee and they think that they can patent this or something like this. So let's say that we are discussing how to disclosure this, but if you can look at my webpage, you can find the paper. In the paper there is like pseudocode, and trust me, you can take out again the real C++ code that we made. Okay. Any other questions? Yes?
What about non-parameter attack vectors like host headers and parameters that are wrapped in XML?
Well, because this is okay, this is good. This is working really good because it's text-based. Because HTTP is really text-oriented. So we didn't test it yet with like pure web services, exchanging XML. But in that case, I would say that we could use, again, the raw data model, and then it's really working good. Poseidon was really achieving good result with text-based content. So I would rely on the raw data model. You can process everything. Because, for example, when we were testing Poseidon on the network packet, we were considering everything. So from the header to the end of the stream, everything was inside, and it was really behaving good. Any other question? Yes.
What about post requests?
Well, the post requests are usually used. Inside you can find or either like parameter like we have seen, like username and password, for example. The password would be really a good candidate for the length, to be used with the length information to catch any kind of attempt.
But it does generate rules based on post traffic.
On what? Sorry?
But the system does generate rules based on observed traffic.
Yeah, yeah. If the point is that, for example, what I wanted to say, if you have a post and you're posting a picture, for example, that is completely binary, you cannot get out any rule from that. So you can, in that case, you will rely on the raw data model. But for anything that is shorter than 15 characters and it's like function, add, delete, equal, or whatever it is, it's really working good, the generation of the grammars of the regular expression. Any other question? So, thank you to have been here.